Hello legends. In this video, I'm going to be speaking about supervised agents and what their use case is. And just quickly, supervised agents are distinct and different to regular AI agents. So we're used to using predominantly this type of AI agent when we're automating workflows and tasks. And what we have here is just an AI agent node in NAN. We have the ability to add some chat model, some memory, and then plug into different third-party tools and software via API calls. And the main difference is that, as you can see, we still have this core AI agent module, which is present in this type of structure as well. But in the supervised agent, we have a lot more human interaction throughout the workflow. Now, the reason that we have more human interaction in the supervised agent system is that because we're actually working alongside humans to complete tasks. For this specific tutorial, I want to be discussing how the supervised agent framework or workflow that you're building, it's actually used to run the logistics of high-risk tasks. Whereas the regular AI agent framework, what we're all used to using up until this point, regular AI agents are used to fully automate low-risk tasks. So at this stage, you might be thinking, okay, well, what's the difference between a low-risk and a high-risk task? And then on top of that, why can't we just build one system that does everything? So that's exactly what we're going to be exploring in this video. And we're actually going to start with question 2 first. So why can't we just use one agent to do it all? And to start answering that question, I'm actually going to go a couple of iterations back. So not starting at supervised agents, not starting at regular AI agents. What we're actually going to do is start by looking at LLMs. And more precisely, we're going to look at their role in automating tasks. Now, the thing that I want us to focus on is that an LLM is actually a probability-based model, where it actually predicts the next word or token that has the highest probability of being shown in a sentence. So let me just give you an example. So I have this input, write a small haiku about AI and how important it is for people to learn it. And we have this haiku result here. Mind forged from our words, future bends to those who teach, and code shapes every dawn. And if I send the exact same prompt or request into a different chat model, you can see that we still get a haiku, but it's actually slightly different to the first one. So mind forged from our words, future bends, code shapes. Silent code, minds shape, learn and drift. So the core theme of code and mind is prevalent throughout both responses. And actually they're kind of similar, but they're not exactly the same. So if we ask ChatGPT to help us explain what's actually going on here, we understand that an LLM predicts the next word or token in a sequence based on the probability of what should come next, given the supplied context. So if we were to say the cat sat on the blank, that the model would then run through a bunch of different possible responses and then rank them based on probability. So for example, the cat sat on the car has a 1% probability of occurring. And this means that out of 100 times, if you kind of give this as the request, 1 out of 100 times, it'll say car, 75 out of 100, it'll say Matt. And then basically what you're getting here is this distribution of probabilities based on what possible output you can get. So what that means is, let's say we have one question and we ask that one question 100 times to an LLM, the exact same question, we get a range of outputs on the other end. It's not fully consistent, it's not the exact same output. Now, this distribution of outputs can be modeled on something like a bell curve. So let's say for an LLM like a ChatGPT 3.5, that every time we ask one of those 100 questions, that 70% of the time we get roughly a similar answer, within an acceptable range. But if you have 70% of the time, you have 3 out of 10 times. So 30% of the time on either end of this bell curve, you actually don't get a suitable answer. Now, this is really important to us because when it comes to task automation, you actually want to have something that gives you a consistent output. So now, interestingly, if we now go across to the first iteration, so from an LLM, we have this jump to an AI agent system. An AI agent system is very similar to the LLM. You can still have an input and output. You get some kind of instructions that you can give. But in addition to what we were used to with the LLM when it first came out, we get the ability to choose different models. We get the ability to plug into different third-party tools. And then we get the ability to actually curate the system message or the prompts. So this is really cool because each of these 3 things, the ability to choose a model, interact with different tools, and customize prompts, these actually serve a bunch of different purposes. The first and most obvious purpose is that by giving the LLM the ability to interact with different tools means that it can actually do more. So it can actually go across to Shopify and get some tracking information. It can go into your task management software and post an update. But what it also does is it gives us the ability to increase the consistency of the output from something like 70% to something like 95%. Now, let me show you how this works. So now thinking of all these 3 things just from first principles, system messages. So over time, from the time when the first LLM came out, so when ChatGPT came out, we've actually gotten a lot better at techniques for creating prompts. So let's say one of the biggest issues was the accuracy of the output. Sometimes the LLM would hallucinate and just generate a response that was totally wrong. Well, you can figure out how to prompt the LLM to say, hey, if you don't have the answer within the contained documents, just say that you don't know versus trying to make something up. So that means as we got better with prompting, we actually got more accurate outputs. The next was tools and actions. So as we were discussing before, when ChatGPT first came out, you had the ability to upload a document into the system, and that document would be attached to the LLM for that chat, and then your LLM could answer questions based on the document. So what would happen is that the bigger the document that you supplied, like if you gave it 1 page, it was a bit more accurate. If you gave it 50 pages, then it was slightly less accurate. And then one of the cool things about being able to integrate different tools to your LLM is that initially when you built an AI agent, you could only use the infrastructure from OpenAI, and they were focused on a bunch of different things, and they had a really good knowledge-based system, but it was not super accurate. So you actually had companies like Pinecone pop up, which all they did was manage that AI knowledge base. And because of that, they made it super accurate. So now when you uploaded 50 documents or 100 documents, that the system would actually give you the exact correct answer. Or if it didn't know the answer, it would just say, sorry, it'd give you an X, and it would say, I don't know the answer and I can't help you with that. So that's how the ability to use tools actually also improved the accuracy, the consistency, and the output of the system. Now, finally, when we first started with something like ChatGPT 3.5, one of the big things here is that the earlier models were not as good at following instructions as the current models that we have today. So as the models progressed, they got better and better at following instructions, where GPT 4.1 is one of the best models available now to actually follow instructions. So now these three actually work in tandem because you can give it really good instructions, the instructions are more likely to be followed, and then the tools that you're integrating with also help with the output accuracy. So now, thanks to all the advancements in the technology, if we were to look at the original GPT 3.5 LLM, let's say we only had a 7 out of 10 times, we had a consistent response. If we have the AI agent model now, GPT 4.1, better instruction following, better tools, now we might go from something like 7 out of 10 times to 9.5 out of 10 times. So the accuracy or the consistency of the response, or the acceptable response for the task we want to automate, is now 95% of the time. But no matter what, we still have these little outliers on either end of the bell curve where we're actually exposing our Achilles heel. And you can see that that's part of every AI experience. If I just zoom into the bottom of this chat, you can see ChatGPT can make mistakes, check important info, and you would see this on all of your favorite tools that have an AI integration. It always says, basically, ChatGPT or the AI that we're using can make mistakes, please check important information. So this disclaimer actually shows us that we cannot expect 10 out of 10 times to get an accurate answer. So now the reason that we would actually try and build a supervised system is because using a human as part of the workflow actually helps us give the workflow a 100% accuracy. So if we're meant to actually be replacing a human with task automation by introducing AI agents to augment processes and tasks, well, in moments where we cannot be 100% reliant on an AI agent system, well, we just have to introduce a human into the workflow. So that's why we can't just use one type of agent system to do it all. So now that we understand that there is this difference in output when you're using agent systems, it's a probability-based system. The best we can get, let's say, is 9 out of 10 times accuracy. Now we can begin to distinguish between these low risk and high risk tasks, where we can just define that for a system that has accuracy of 9 out of 10 times, we get the desired output. A business is willing to accept that tolerance for a low risk task. But then for these higher risk tasks where there is no margin for error, it is not willing to accept 9 out of 10 times accuracy, and it can only use 10 out of 10 times accuracy. So to start understanding the difference between these low risk and high risk tasks, we look at something like an organizational chart. Now, if you haven't seen or heard of this thing before, an org chart is a map of all the roles in a company along with their area of responsibility, so the tasks that they have to complete. As you can see, we have the CEO up top, who is responsible for the team managers, and the team managers below them have team leaders, and each team leader might have different staff on their team. So depending on the size of the team, there might be fewer layers between the CEO, the manager, team leader. It might just go from CEO to a team head, and that team head actually performs all the tasks. Or if you have bigger teams, then you probably have a lot more managers in certain positions, a lot more team heads, and then a lot more workers underneath them. So an org chart varies based on the size of the business. So an interesting way to interpret an org chart is to assume it means that the role at the very top of the org chart, so it's like a tree with branches that comes down, the role at the very top carries the most risk, and the role at the bottom carries the least amount of risk. So let's say we look at a slightly more simplified version of an org chart. Up top, we have the CEO who is responsible, let's say, for the strategy of the business. A bad strategy could mean they miss out on sales, the business just goes under. They're responsible for all the key decisions. Now, the CEO cannot possibly do absolutely everything in the business, so the CEO hires a bunch of different team heads to run certain departments in the business. And this means that some of the risk that the CEO has to carry for the business is now delegated and distributed down to the department heads. Now, each department head, let's say they're responsible for executing the strategy. So the CEO says, this is what we're going to do. The department says, cool, let me run that with my team. And now each department head has a number of staff on their team that actually run the processes and do the jobs for the business. So an ultra simplistic way to look at this is that the people at the third level carry a lower risk than the people at the second and the people in that first or that CEO level. So the third level was actually what's ripe for automation with AI agents. So if we look at our own org chart over here, we have the CEO, we have the heads of the teams. The head of the marketing team might have 3 different divisions. So someone that's responsible for the website, or a team that's responsible for electronic direct mail, so sending mails out to customers, and a team that's responsible for creating content. And then in that content team, there might be a person that does all the images and videos, a person that writes all the posts, a person that writes all the copy for the website. And then drilling in a little bit deeper, the person that creates the posts, their responsibilities for the business are to create and post on Facebook, on LinkedIn, and on Instagram. So you probably already know now that you've seen a lot of NAN workflows, or you've delivered workflows to clients for content creation, like creating posts and posting it on LinkedIn and Facebook, or maybe you've done this for yourself. And that's because creating some kind of post is a low risk task. Because of the systems we have now, you could upload your company information, for example, into Pinecone and attach it as a tool. You could upload your specific set of instructions. You can use a model that follows those instructions very accurately. And you know that you can get a very consistent and accurate output for 95% of the time. So the risk to automate this role is fully acceptable. 95% of the time is actually good enough. So you can see that on this level, a lot of these roles would be automated using AI, or at least, augmented. So like the AI is helping to create this content. So images and videos, we're seeing a lot of that now, posts, website copy. So these writing tasks are very popular. So now let's take a look at customer support. So much in the same way, you have the head of customer support, you have team leaders, and each team leader might be responsible for 5 human customer support agents, where each agent, their task is to respond to customer questions, help with troubleshooting, do some order management. So yeah, customer support was super, super popular for introducing AI agents into. Actually, one of the first use cases for these LLM systems when they first came out, before they were as advanced as AI agents, was to actually help build automation for customer support. And a lot of businesses initially in those early days didn't actually generate responses and send them. All they did was generate draft responses for their agents. So a lot of businesses, there's like a 50-50 split right now that I'm seeing, where people are actually still generating draft responses because the risk is a little bit too high for them. And then there's another 50% of people that are now using these AI agents and actually sending those public responses directly back to the customer. So much in the same way as before with the previous content generation agent we spoke about for the marketing team, responding to FAQs, troubleshooting, order management, we're able to get really specific instructions. We're able to plug into tools like Shopify for order management. We've got great models that help us follow the rules, so that automating something like customer support is actually very accurate. And it's at this stage that we can actually start to distinguish between these high and low risk tasks in a very tangible way. So we're just speaking about customer support and that content generation. That's a low risk task. But now, how do we actually identify a high risk task? So a very typical setup for customer support is that a human agent will handle all the tier 1 requests. So like the general questions, initial troubleshooting, order management. For anything that is a little bit more complex, let's say the use case is that the customer is very angry, threatening to leave a bad review, is demanding to speak to a manager. You actually escalate the tickets from a customer support to an escalations manager, or a team leader in this case. So now the team leader has some responsibilities as well. And their responsibilities might be handling escalations, so getting all the frustrated customers and trying to manage them so that they don't leave bad reviews, and to kind of bring them back down to a neutral state. And they might also do different things like help manage shifts. If someone's away, they would fill the shift, and they would also help train agents. So if a new product comes out, they would develop some material for the training, for the resources, and then train all the human agents. So what we've just discussed is that the customer support agent is actually able to handle the majority of customer support tickets. But if there is an escalated ticket, we actually still need a human touch to handle that escalation. And this is the case for a lot of businesses. Businesses not really giving these escalations completely to these AI systems. Because if you fail with this escalation, that actually turns into a bad review, or that actually turns into a refund. So therefore, this is a high risk task where you really want 10 out of 10 accuracy. So now we circle back to this supervised agent framework. And what we're going to be looking at is how we can actually use an AI system to run the logistics of the high risk task. So we start off by looking at a very generic customer support automation workflow. This is not production ready, so I wouldn't copy this. But let's say we get a new ticket from a customer and we immediately plug it into this classifier. And the role of the classifier is to identify if the ticket is a general support ticket that we can give to the customer support agent, or if it's an escalation where the customer is visibly frustrated and they're demanding a refund or to speak to a manager. In this case, all we're doing is we're handing off that ticket to a database, which is that process that we described before, where the CS agent sends it across to the team leader, so the team leader handles the escalation. So now we finally look at a supervised agent framework. So what we're doing here is we're plugging into the database every time the escalation is added, and we're triggering the start of this workflow. By the way, this workflow is available on one of my other customer support escalation videos. I'll link that in the description of this one. So you'll be able to go ahead and watch that video, understand how this works, and download the resources. And then we're taking that escalation and plugging it into this initial agent. So the task of this initial agent is to actually go off and do all the research, get all the data, get all the details that relate to this escalation, and then based on predefined policy for escalations, to present a proposed resolution that we then send to a human. So escalation is added here, we trigger the workflow, the agent then goes off, reads the escalation, goes into Zendesk, which is a customer support tool, to look at all the previous communication with that customer, looks at the known issues database to understand are there any product recalls, checks the tracking of that order to understand what's the context. So then in our prompt, after the agent actually collects all the information by using the two tools that we gave it, we can now also tailor the experience for escalation. So you have the power to, aka here are the policies you must adhere to, offer refunds. If a part arrived missing, you can send the replacement part for free. So we give the agent all the company policies that we have around escalations so that it can actually propose a resolution for us. We then take that escalation and then create a package of information that contains the escalation information itself, any additional context relevant to the escalation, as well as a proposed resolution that adheres to the company policies. And we send it off to the human escalations manager to actually review and then give us either a thumbs up or a thumbs down with some additional feedback for changes we need to make to the resolution. So assuming we get a thumbs up, we just send it across to another agent system to then actually roll out the changes, so apply the refund and then respond to the customer. Or if we get a thumbs down with some feedback, we then send to another agent system to just modify the actual proposal, and then we still end up sending it out to this agent to run those actions and respond to the customer. So as you see here, we're actually using these agents to collect data, collect information, complete tasks, and actually run the logistics. But the ultimate decision, that high risk decision that does need the human touch, so it's 10 out of 10 accurate the entire time, that high risk decision just sits with the human. So now the benefit here is that all this time spent reading the escalation, going to all the different tools, getting all the information, completing the different tasks. Let's say this takes the human 15 minutes or half an hour to complete. It just takes them 1 minute to review the information and give a thumbs up. So this is massive because let's say the escalations team was responsible for handling 5 escalations a day or 2.5 hours of work. We've now condensed that down to just 5 minutes of reviewing these proposals. So that's the whole idea here. We're using supervised agents to actually run the logistics of tasks, help augment and prepare information, summarize research, generate proposals, and just help save time for humans. So all they need to do is just thumbs up and thumbs down. Now there's actually a bunch of use cases for the supervised agent framework, more than just customer support. Now I'm just going to touch on one final use case here before I end the video. But if you want to see a deeper dive into this topic and me going over a few more use cases for the supervised agent framework, I'll be doing that in my school community. So if you do want to see more information, I'll leave a link to my community below. And in the next couple of days, I'll be creating some more exclusive resources on this topic for the community. So yeah, feel free to join if you want to learn more. So a very popular use case for this framework is in the professional services industry. If you're a law firm, every time you get a new engagement from a client, it typically comes with hundreds or thousands of pages of resources of this material, which could be emails, SMS exchanges, just documents, plans, PDFs, image, everything. And you have to be able to synthesize that information, understand the area of law, and then provide a recommendation to the client if they have legs to stand on or not. So this process is very time consuming, and a lot of law firms are still using human labor to actually run this. So let's say you're the managing partner, you get 10 of these cases a week. You now have to get this case, you have to start the process, you have to go to all the different members of your team, you have to knock on their door, get them to read sections of it, give you responses back. They might be late, the timeline might draw out, you might need more information, more research. And then at the end of the day, the client might actually say, actually, I don't want to go forward with this case. And in some cases, you might not be able to quote the client for this pre-work until they sign the contract. So it's actually a massive opportunity for the legal industry to introduce a system like this, where the managing partner might actually drop the new case or the new engagement into a form and explain what has to be done against it. The automation will then add that file to a shared Google Drive. It'll build a plan and a schedule. So everything has to be done by Friday. I've got to loop in X, Y, and Z team members. It creates the plan, and then it creates the timeline in Google Sheet. And then the second phase of the system will actually go to that timeline every day, understand if something has to be done on this day, and gets the plan, gets the files, and essentially we're running it through an agent system that is able to automate some of these tasks. So it's able to loop in humans and ask them specific questions at specific times to get their input. It's able to do additional research. And then you can actually go into here and add any other task that needs to be done. So a task that should be here is actually, let's say, synthesis or summary of the actual documents. So you just go off and you create these different tasks, these different routes, and now your agent system is actually able to handle the logistics of research, summarization, going to different humans, waiting for their feedback and input, updating case files and timelines. And then the final stage of the system would then send the recommendation across to the managing partner. So just like for the customer support, where we had the original issue, all the context for the issue and the proposed resolution, we just do the exact same thing with each case that comes in. And that could actually save the law firm tens or hundreds of hours depending on the size of the engagement. And that means that now, instead of being capped at 5 new engagements per week before you actually have to hire more people for your team, you can take on 5 engagements per day because the system is fully automated and you get the right information at the right time so you can make your recommendation. All right, guys, thank you very much for watching this video, and I'll see you in the next one.